Okay, so we have a right triangle, and we're going to try to find the center of the inscribed circle. For now, I'm not going to worry about it being 5, 12, and 13. It's just a right triangle.
All right.
Okay. How do you think we do this?
Well, each of the there's 3 points that's tangent to the edges of the triangle.
Okay, yeah, that's true. I'll do my best to draw it. So you're right, there's 3 points where it's tangent.
I don't necessarily know where those points are.
No, we don't. Do you have any ideas?
Well, I know a couple things. So I'm going to say that I'm going to put this on, like, do one of the, like, the exact location of the center of this.
Yeah.
So I'm going to put this triangle on the coordinate plane.
Okay.
With this being 0, 0.
Alright.
And well, I guess it's fine if it's going in the negative direction here.
Yeah, that's fine.
So we know this is a 5, 12, 13 triangle. And we'll do it in the center of this triangle, or do you just want it for a general right triangle?
For a general right triangle.
Okay. Well, so we know that this distance here is r, the center is somewhere over here.
Alright, so the center is somewhere here. Okay.
And this distance here is r.
Alright, why? Why is that r?
Well, because it's the distance from the center to the edge of the circle, which just happens to touch the right triangle in that point.
Alright, it's the distance.
It's just the radius right now.
So all of these distances are r. Okay.
And in a right triangle, this here is a square.
Alright, why is that?
So the points, the radius will just, the points that are touching will just go, the center will go horizontally and then vertically down.
Yeah, but why? Why is this a right angle and why is that a right angle?
Well, I think it's just because, like, of how the circle is in the triangle. The circle's here and it's going to touch on this side. Sort of like that.
Yeah, that's true, but there's some reason, there's an important reason. Even this is a right angle here.
Well, these lines are all tangent to the circle.
Ah.
And when you have tangent lines to the circles, the radius that goes to them makes a right angle.
Okay, so these are tangent lines, and then the line coming up from the circle meets those tangent lines, and it's perpendicular to them.
Alright.
Okay. So that's important. So we do have a square here, so that's nice. What else do we know?
Well, we know that we're going over r in this direction. This is r and that's r as well.
R. So I'll call this a minus r, and I'll call this b minus r over here.
And we also know that this is a minus r, and this is b minus r.
A minus r, b minus r. That's true. Why is that true?
Well,
What's the geometric idea here?
well, what you're doing, so you're just from the center, and you split the lines off. They're gonna the tangent points will be this is not necessarily the same. It's the same distance here.
Okay, so do you know the geometric idea?
Well, angle bisectors are always the same distance away from the two sides.
Okay.
And at this point, it's the same distance away from the two sides. So if you draw the line from this point here, that will be an angle bisector. And therefore, you will have two similar triangles. You'll have the same angles here and the same angles there and the same side there.
Okay, yeah, good. That's a good explanation with angle bisectors. But that's an equally good explanation is if you have a point outside of a circle, the tangent lines to the circle from that point always have the same length. It's basically a symmetry argument.
Yeah.
Okay.
And it kind of comes from the angle bisector.
Yeah, that's exactly where it comes from. All right, so how does this help us figure out what R is?
Well, like what the length of the radius is?
Yeah. So right now we can actually know what the length of the radius is in terms of the side lengths of the triangle. Because remember, we have a right triangle here.
Well, we know that a squared plus b squared equals b minus r plus a minus r, whole thing squared.
Yeah, normally we would call this c.
Yeah.
Okay, so there's even an easier relation.
So b minus r plus a minus r is c.
Alright, so c equals b minus r plus a minus r.
Which means that so we can move the c to the other side and move the r's to this side. Okay. We can see that 2r equals a plus b minus c.
2r equals a plus b minus c.
R is a plus b minus c over 2.
Right. Okay, so we have a 5, 12, 13 triangle.
So we're calling side A BC.
Yeah.
So it's going
5, 12, 13.
So it's
You said so.
Oh, sorry, 12.
So it's going to be 12 plus 5. That's 17 minus 13. It's going to be 4. It's 2r, so r is 2.
R is 2. Okay, awesome.